right, let's dive into one of the biggest challenges in any SD-WAN deployment, securing that direct internet access at your branch offices. In this explainer, we're going to walk through exactly how to implement some really robust web security in a Cisco environment. We'll cover the key features, the design choices you have to make, and all that operational know-how you need to really get it right. So here's our game plan. We're going to kick things off by comparing the two main ways to do this. Then we'll really get into the nitty-gritty of URL filtering. After that, we'll look at the database that powers it all, tackle that huge challenge of encrypted traffic, talk about real-world deployment, and then wrap up with how to monitor and troubleshoot the whole thing. Okay, so let's get right into it. When you're talking about securing web traffic in SD-WAN, your very first big decision is this. Are you going with DNS security or URL filtering? Now, they might sound kind of similar, but trust me, how they work and what they can do are fundamentally different. This table just lays it all out perfectly. You see, DNS security is a cloud-first approach. It only looks at the DNS request itself to make a call about an entire domain. But on the flip side, URL filtering is an on-box feature. That means the intelligence is running right there on your edge router. It actually inspects the HTTP packet, which gives you way more granular control, but, and this is a big but, it requires a dedicated 8 to 16 gigs of memory to pull it off. So, to put that in real-world terms, with URL filtering, you're not just blocking, say, badsite.com. You can get super specific. You could allow access to just one corporate portal, like sharepoint.company.com, while blocking literally everything else on that company.com domain. That level of precision, that's the real game changer here. And I love this diagram because it shows the decision logic so clearly. Just think of it like a funnel. Every single URL request first gets checked against your custom allow and block lists. These are your non-negotiable, always allow or always block rules. Now, if a URL doesn't get caught there, it drops down to the next level to be judged on its category, things like social networking or gambling, and its reputation score. Let's move on to the mechanics and see how this engine actually makes its decisions. We've seen the high-level logic, right? So now let's break down the different pieces that all lead to that final allow or block verdict. The engine really just boils down to these three core methods. You've got your list-based filtering, which we just saw. That's your explicit allow and block rules. Then there's category-based filtering, where you can just wipe out whole classes of websites. And finally, you have reputation-based filtering, which judges a site based on how trustworthy it is. Now, what's really powerful here is how reputation is quantified. It's not just some vague good or bad label. Nope. Every single URL gets a score from 0 to 100. As the administrator, you just set a threshold. So, for example, if you set your policy to moderate risk, the system will just automatically block any URL with a reputation score of 60 or less. It's a really simple but super effective way to enforce a security baseline. And the process for any given request is incredibly straightforward. A user over in a branch office tries to go to a website. The WAN edge router snags that request and redirects it internally to the URL filtering engine. The engine applies the policy we just talked about. If it's blocked, the user gets a nice little notification page. If it's allowed, the connection just sails right on through to the internet like nothing happened. And this diagram just ties it all together beautifully. The big takeaway here is the central role of that WAN edge device. It's not just a router anymore, it's your security enforcement point. It intercepts the traffic, talks to the internal URLF engine, and then makes the final call, all before that traffic ever even thinks about leaving the branch. So we know how it decides, but what intelligence is it actually using? Let's take a look at the brains behind the operation, the on-box URL database, and its really critical connection to the cloud. The system uses this really smart hybrid approach for performance and scale. For speed, the WAN edge router downloads a local copy of the URL database. This lets it make decisions on common URLs almost instantly. But what about all those new or obscure websites? Well, that's where the cloud lookup comes in. If a URL isn't in the local cache, the router just queries the master database in the cloud. So you get the best of both worlds, super low latency decisions for most of your traffic, with the massive knowledge of the cloud as a fallback. And this is where the system's security-first thinking really shines. When it comes across something it doesn't know, it defaults to being cautious. If the cloud sees a brand new URL it has never ever seen before, it assigns it a reputation score of 40, which automatically puts it in the suspicious category. This makes sure that unknown sites are treated carefully. Interestingly, though, it totally trusts internal private IP addresses, giving them a perfect score of 100, while treating those weird, non-routable domain names with that same suspicious score of 40. Of course, none of this really matters if you can't see the traffic, right? And on today's internet, pretty much everything is encrypted with HTTPS. This creates a massive challenge, so let's take a look at how URL filtering deals with it. Okay, this side-by-side comparison is absolutely key to understanding what this system can do. Without decryption, the engine's vision is pretty limited. It can only see the domain name from the server certificate during that initial TLS handshake. That lets it block domains, sure, but not specific URL paths. But when you enable SSL/TLS decryption, the router basically becomes a man in the middle. It decrypts the traffic, which lets the engine see the full HTTP GET request and the exact URL the user is trying to get to. This is what unlocks that granular control we were talking about earlier. And here is a classic operational detail that trips people up all the time. If you block an HTTPS site without using decryption, you can't redirect the user to a nice, friendly block page. Their browser will just throw a generic connection error. So to give your users that seamless experience where they're actually told why a site was blocked, you absolutely must have TLS decryption enabled. Okay, let's pivot from all the theory to actual practice. You're ready to deploy this, but before you just jump into vManage and start clicking away, there are some really essential design considerations and limitations you have to know about. This slide sums up the 7 most important things to think about during your design phase. We're going to highlight a few of the most critical ones in a second, but you should probably review all of these before you even think about rolling this out into production. Let's focus on 3 key limitations here. First, your custom allow and block lists are capped at 64 entries each, so you've got to use them strategically. Second, the system matches on static URL patterns, so it doesn't support those dynamic URLs with constantly changing bits. And third, it's not really designed for micro-application blocking, so for example, you can't use it to block Facebook Messenger while still allowing the main Facebook site. And then, on the requirements side, these 3 are absolutely vital. That cloud lookup feature needs internet connectivity through a NATed interface on the router. And crucially, if that direct internet access or DIA circuit goes down, there is no fallback. It can't use an MPLS circuit for those lookups. It's a hard dependency. Finally, if you need detailed user-level logging for compliance or something, you'll have to export that data to an external SIEM server. So the system's deployed, your policies are active, traffic is flowing. Now what? We need to manage it. Let's wrap things up by looking at the tools you have for all that day-to-day monitoring and troubleshooting. Your first and easiest stop is going to be the security dashboard right inside vManage. It gives you these great high-level graphical views. You can quickly see which categories are getting blocked the most, whether it's by reputation or by specific categories like games or social networking. It's perfect for just getting a quick pulse check on your security posture. But for the really deep diagnostics, you're going to need to drop down to the command line interface of the WAN Edge router. This is where the real power is. This slide lists out the essential show commands you'll be using to verify configs, check stats, and view what the engine is doing. Let's look at a couple of quick examples. For instance, this command, show UTD engine standard statistics URL filtering, is just incredibly valuable. As you can see from this output, it gives you a super detailed breakdown of exactly what the engine is up to. You can see total requests, how many hits you've had on your whitelist or blacklist, and precise counters for how many URLs were passed or blocked. This is your ground truth when you're trying to diagnose a problem. And finally, it's really important to remember that URL filtering runs as part of the Unified Threat Defense, or UTD, service. Using commands like show app hosting list and show app hosting detail lets you confirm that the underlying container service is actually running and has all the resources it needs. You can check its state, the software version, and see the memory and disk reservations, just making sure the foundation of your security service is healthy. So as we've seen, Cisco SD-WAN really does provide a complete framework for web security. From that initial design choice all the way down to these granular CLI commands, you've got a full tool set at your disposal. I guess the real question is, now that you're armed with this knowledge, what's the first change you're going to make to improve your branch security posture?